Hello, and welcome to Not a Buffalo, the show where we discuss the science and technology that will save the world. My name's Jack, and I hope you're all feeling safe and well wherever you are in the world. This is Ben, and he's forgotten what the world feels like. Now, I should have said wind there, because that's what it says in the intro, but I prefer world. Now, Ben, how are you?
I think world is accurate, yeah. I've forgotten what anything feels like. I've not been beyond the apartment gates in I don't know how long. Light years, it feels like. And that's not even a measurement of time, so that's how much sense I'm making right now.
But it's nice that you have an apartment where light years are a usable metric.
But given the distortion of time, it feels like a light year is actually only about 4 potatoes long.
Yeah, but I mean, you've got all that freedom in your potatoes, so...
That's true. Potatoes are freedom. Potatoes are freedom.
I think it's 4 freedoms to the potato. Is that's how the imperial system works, right?
Yeah, but we use the metric system here, so it's 18 freedoms to 7 potatoes.
That makes sense. That does make sense.
How are you, Jack? I didn't ask. How are you?
I'm well. I'm sort of out of sync with the metric system. I've been measuring stuff in meters. I'm behind on the potato related developments in the system.
Oh, I see. Sorry. Yeah, well, given that I haven't been outside, those developments may have only happened in the feverish imagination of my own mind, so I wouldn't worry about it too much. But you're enjoying lockdown? You're enjoying...
As far as I'm concerned, I could have been built for this. This is ideal. Like, I've been working on creative stuff. I've been doing lots of online courses. I don't miss outside very much. I don't miss the cinema. I don't miss going to the grocery store. It's fantastic. As far as I'm concerned, things can stay like this for a very long time, and I'm just going to get happier.
So this episode is going to be called Everybody Hates Jack, because Jack is one of those people who can not only adapt to situations, but also just makes the most of them. He's written an album. He has going to enter the online version of Mr. Universe because he's been working out all the time. He's got a new job, and it's going to, I don't know, build a really effective system of some kind that's going to be really good. And yeah, he's just bettered himself in every way, and it's really annoying.
It's so much fun. Life is so good. I'm sure that's what everyone wants to hear right now, is that life is really, really good, and I'm really happy.
I've literally been scheduling my time between playing computer games and PlayStation games. That's been my lockdown.
I've been experimenting with like abstract painting techniques. I've been having great fun.
You know what? I quit. I'm out.
So Ben, do you have any stories for us now that we've generated quite a lot of unusable content?
I do. I actually do. I've got a really interesting story that involves hunting for George Clooney's face.
I like it already. I like this a lot. Tell me, how do we hunt for George Clooney's face? How can we do this? How can we find him, Ben?
First off, as with many of my stories, this one struck my eye. This one caught my eye partly because the name of the guy is Thackeray Brown, which I think is a great name.
That's a great name.
But he's at Stanford University in California.
I think Stanford should only admit people with really fantastic names.
That may be one of the criteria. I've never gone through the staff list at Stanford University, to be honest, but it could well be. Yeah, so they got 38 people with an average age of 23, so mostly students, I'm guessing, and they asked them to navigate a looping path around a virtual town that they'd simulated in a simulated environment. And at one point along the route, they put a picture of a face of a celebrity, in this case, George Clooney. I think they used George Clooney for some of the participants. If not all of the participants, then some of those participants really missed out. I feel sorry for them for having to look at a celebrity who's not got George Clooney's face. What they then asked them to do was to navigate the simulation again whilst lying inside an fMRI machine, and they put the participants in an unfamiliar location, and then they had to try and find the celebrity's face as fast as possible.
Cool.
And the towns were designed so that a previously unused shortcut was the most effective way to really reach the celebrity, and the towns were small enough that people should have been able to work this out. But what they did to half the participants, 20 participants to be exact, was they made them wear a device on their ankle that gave them electric shocks at random intervals.
Did the participants know they were wearing this device, or did they think that they were being shocked because they were in the town?
No, they knew they were wearing this device.
Okay.
And
I prefer my way. I know that's not good science, but I just think it would be more fun.
Potentially.
Carry on.
So they gave these participants electric shocks at random intervals, and they found that the ones wearing this ankle device took the shortcut less often, so they only took it 31% of the time, as opposed to the other group, which took the shortcut 47% of the time. And the ones who were being shocked were also slower to reach the celebrity. Now, the point of all of this study was to check stress, essentially. So they were monitoring the neural pathways within the brain through the fMRI machine. They were also looking at their cortisol levels, which cortisol is a hormone that is a stress hormone, basically. So when you are stressed, your body increases production of it to help with the fight or flight response. And they basically found out that if you get randomly shocked and are tasked with finding a celebrity's face in an unfamiliar town, you are going to be fairly stressed.
What you really want for that experiment is a control group who get really relaxed when they're shocked.
That is a really specific requirement. I'm not sure how easily it would be to find people who get relaxed by electric shocks.
I was thinking that as I said it, and I was like, yeah, maybe it would be hard to find people who really relax when they're electrocuted.
Yeah, I mean, you might have to condition people from a very early age to associate electric shock with being relaxed, and that would just take a long time to do what is probably a fairly simple experiment otherwise.
Yeah, you'd probably have trouble clearing that with the ethics board as well.
Oh yeah, that too.
To train children for 15, 20 years in some kind of electro camp.
Potentially. I should mention, the point of this study wasn't just to try and make people stressed, but they actually did some really interesting tests in this experiment as well. So one of the things they did was they used a machine learning algorithm to decode the fMRI data, and they were trying to figure out where the participants were looking, because they were using landmarks in this virtual town to navigate their way around, and they found that non-stress participants could imagine all of the landmarks along the route, whereas stress participants just focused on the landmarks that were closest to their starting point. What they were really looking for is how stress affects us in the real world and how we can cope with stress, so trying to look at how we can deal with things like PTSD, but also just stressful situations as well. So some really interesting kind of studies that really important aspects of the human experience that they're trying to understand and help us cope with, but just quite a funny little story to start off with. But anyway, yeah, that's my first story. What about you, Jack? What's your first story for us today?
My first story is also about electricity.
Okay.
So it's about the fact, not widely understood, that Saturn is essentially a toaster. I'm very happy that listeners should know that this is the second recording we're doing of this.
No, it isn't. We're perfect. We do everything in first take.
It's okay, Ben. It's okay.
Fine.
It's okay. To err is human. I'm representing my stories to Ben, but I'm doing it in a ridiculous way each time, and I'm catching him with it, and I'm making him laugh. And this is basically my aim for the podcast.
So Saturn's like a toaster.
Saturn's like a toaster. That's my news story.
To explain.
Do you remember little old Cassini?
Oh yes, the probe that we sent out NASA sent out into space. I had nothing to do with it, but I'm glad it did.
You and me, Ben. That's our baby there. NASA didn't steal it from us, it's theirs. So for its death dive, it was diving in and out of Saturn, and part of...
I feel like you should explain death dive before you move on.
Death dive, it's a scientific term, which is how you dispose of satellites in the most fun way, whereby you dive into Saturn's atmosphere and the friction naturally causes damage, because satellites are generally designed to work in no atmospheres, and Saturn has lots, because we measure atmospheres for Earth's atmosphere, and Saturn's a lot larger, so it's got a lot more stuff around it. Anyway, so a death dive is a sort of dive into that sludge and then coming back out of it, and then diving back into it and coming back out of it. And while this is also the most fun way to dispose of a satellite, it's also relatively useful because it was able to measure the heat in different parts of Saturn as it went up and down and up and down. And I don't know why I'm doing gestures with my hand, because we're not recording a video for this.
But I can see you, so I'm enjoying it. And I'm glad that you made the extra effort for me, Jack.
Well, this is why disposing of satellites can be fun, is because then we can do gestures to them. And in essence, whole choreographed dance routines.
Let's try and do a corrugated dance routine instead. That sounds like a way more of a challenge.
I imagine Iron Man doing the robot.
But like the first Iron Man that he built in the cave out of the corrugated bits of iron and stuff.
That's what the movie should have been, is just Robert Downey Jr. dancing in a cave. But yeah, so Why were we diving in and out of Saturn? That's probably the next question to ask about this. And the answer is that we thought Saturn was going to be quite cold because we're simple beings and it's further away from the sun than we are. So we thought it would be colder than we are.
Makes sense.
Yeah. And then we went by with the Voyager spacecraft and we were like, oh, these outer planets they're warmer than they should be. Like way warmer, like 200 degrees C warmer than they should be.
That's quite a lot. For Americans out there, that's quite a lot.
Yeah, I don't know what it is in the wrong system. I don't know Fahrenheit.
Imagine 200 is a big number in Fahrenheit as well. I don't know.
Yeah, I mean, the predicted level was negative 123 centigrade, which does sound like they just made it up.
But they accidentally deleted the data and just type in anything. Quick!
Oh, okay. I don't know what we should predict Saturn should be. That's my best scientist. But yeah, so just put 123 and it'll be fine. No, don't tell Keith. And then of course Voyager goes by and Voyager finds out, much to Keith's chagrin, that it was actually 125 degrees positive C, but it could go up to 325. And Jupiter and Neptune actually exhibit even higher temperatures than Saturn. So
we found that Jupiter and Neptune, which are also gas giants, have higher temperatures than we'd expect as well, based on the modelling. So do they know the reason, what's causing this?
Well, they think it's the aurora, basically. So they think it's charged particles from the sun hitting the planet's magnetosphere, and then that sort of conducts them, because the aurora is actually an electromagnetic effect. And in the same way that electromagnetism is what's used to heat toast, you just sort of string some wires and you put some electricity through it, and that heats up the wires, and that's why you get a lovely pattern on your toast. But yeah, so that's my story, is that Saturn's aurora basically acts like the wires on a toaster. Do you have a segue to get from toast?
I just wonder if it happens to another well-known gas giant, Uranus.
I like that you're reusing your segue.
I mean, it's such a good segue. It's such a good joke.
I think that's one of the best, actually, that you've ever done.
Anyway, yeah, so, and I believe the pronunciation now is accepted as Uranus, but it is a very large gas giant planet, and also very icy, we think. So Uranus is very unusual amongst all the planets in that it's tilted at 98 degrees, which is a lot more, so tilted along its axis. And you can see that it actually has rings, and it looks like, rather than Saturn, which kind of look like they're going round the middle like you'd wear a tutu, Saturn, it kind of looks like they tried to pull the tutu over their head and it got stuck and they've just given up and are wearing it like
now
that.
They're just ringing Uranus.
Yeah. Exactly. But some scientists at the Earth Life Science Institute in Tokyo, at Tokyo Institute of Technology, have modelled what happened to it. And they think that in its dim and distant past, Uranus was probably struck by a icy planet about 1 to 3 times the size of Earth. And it basically just tipped it over and left behind the debris from it, left behind the moon and the ring system around it. Sorry, it has 27 moons. And they were all left behind by this icy planet that just struck it. And I just think that's amazing to think that they've been able to figure that out. And then I was kind of like, that's really terrifying that there's a bit of space rock can just come whizzing past and just tilt the entire planet over. If Earth got hit by something like that and tilted over, it'd be quite a big deal for us. We'd find that quite uncomfortable.
Probably be the last deal for us.
Yeah.
If something 3 times the size of the Earth were to sort of just go, oh, hey Earth, I think let's be friends.
Luckily, now that we're no longer in the early universe and things have calmed down a little bit, astronomologically speaking, or whatever the correct word is.
Astronomological. I like it. Astronomological.
Astronomological. Yeah, that's the word.
Astronomological. I love it. It's delicious.
Yeah, so Earth is unlikely to be hit by anything like this, and there is NASA have a plan in place to deal with any asteroids coming towards us, and which is interesting. But that's a side note. But basically, yeah,
what is that plan? Just out of curiosity, I imagine they can't do that much without funding.
I actually think it was the Japanese space agency sent a probe into the asteroid belt, and that was able to move an asteroid into the way of another asteroid to knock it off course, and that's what I think they're planning to do. If they can. I don't know if possible, or if they have like a meteor on standby.
just in one of the parking spaces at NASA.
Yeah, they might just have a giant meteor that they can... or maybe they just... I kind of imagine they just use the moon. Like, they just send up a load of spaceships and they'd slow down the moon and kind of push it back so that it would then hit the moon. But that'd probably have disastrous ecological consequences as well.
Yeah. I can't imagine you'd want to use them, because you can also really only do that once. Like, once you've smashed the moon to bits and you've got a brand new asteroid belt around the Earth. Yeah, it feels like that would cause more problems than it would solve.
Yeah, potentially. But we hopefully won't have to worry about that anytime soon.
No, it's not like... No life's ever been wiped out by asteroid, really.
No. By giant penguin eggs? Yes, but not by asteroids.
Yes, exactly. That is why you never trust giant penguins.
This is true. If you don't know what we're talking about, see our previous episode, Penguin Dino Killer, for more information.
I'm really impressed that you remembered the title to that, because I just remembered that there was a news story related to it in there.
It's a very memorable... I'm going to check I've actually got that correct now. I may have got it wrong.
I think you're right. I think that's right.
Penguin Dino Killer, yeah, it is. Episode 7.
See, listeners, if you ever doubt that Ben does productive stuff while he's in quarantine, doubt no longer. Ben knows our whole back catalogue, and so should you.
Listen to them all every day until there's too many to fit into a day.
I think we're a good 8 months off that.
Yeah. Oh, I forgot to mention, happy birthday.
What for?
It's not a buffalo, it's a year to the day that we released our first podcast.
Oh, is it? I didn't... Oh, that's amazing. Happy birthday, Einab brother.
Yeah, and we are putting up a picture of Jupiter on this day because it is the picture that Hubble telescope took on the 21st of April 2019, and you can go and see what did Hubble see on my birthday, which is quite cool.
That's really cool. Oh, I like that.
So look out on that for the social media. I mean, it will already have probably been and gone by the time you hear this episode, but
yeah, we can always pin it for anyone, or link to it in the show notes or something.
The other interesting thing about Uranus... No, I'm sorry, I couldn't do it seriously.
Hello.
Its day is only 17 hours long, and they also think it's because of this impact, because it hit it and started spinning it really fast.
Fast spin, yeah.
It's amazing to think of Uranus is dozens of times bigger than Earth, and it's mad to think that something can come along and just make it start, like, tip over and start spinning really quickly, and something did.
You'd never need a centrifuge.
No.
Really, would you? Like, because I was wondering how fast the surface would be moving.
I don't even know the speed of the Earth, so couldn't even figure it out relative to that. Probably pretty quickly.
Yeah, let's go with pretty quickly. I like that as a metric.
That's in the new metric system that I've devised. Pretty quickly is now.
Is this new research then that's turned up the whole planet hit the planet and then the planet was on its side? I'm really bad at this today. Planet hit Uranus and then Uranus was on its side.
Yeah, so it's basically a new study from Professor Ida at the University of Tokyo. Professor Ida at the Tokyo Institute of Technology, and yeah, it's a new way of modelling it that they've looked at, and obviously trying to learn and understand a bit more about our solar system and as a result the wider universe as well. But it's a new model that they've created and kind of related to your story. So yeah, just came across it and thought, that sounds pretty interesting.
My next story is also sort of related to the distant past, but it's not quite as distant as 4.5 billion years. Was that what it was? 4.5 billion, you said?
No, that was...
Oh, sorry.
They were comparing it to when Earth's moon was formed was about 4.5 billion years ago. It doesn't actually say... I don't think they actually figured out exactly, or they don't have an estimate as to how long ago this happened to Uranus. Somewhere between a long time and a really long time ago.
Well, that's even better, because my story is about a long time ago, but it's not in a galaxy far, far away. It's right here on Earth, but by the South Pole.
Did it still have penguins?
That's exactly what this story is about. And by exactly, I mean not at all.
I knew that was coming, and I still couldn't help laughing at it.
Penguins were not located near the South Pole, probably, unless they were very warm weather penguins. Because this study revealed that roughly 90 million years ago, a rainforest was growing near the South Pole.
Like an Amazon in the South Pole.
Exactly like an Amazon in the South Pole. The actual image they've got on the article, which I think it looks kind of like the Lost World.
Oh, cool.
Yeah, Who doesn't love Arthur Conan Doyle's other character, right? Everyone knows Sherlock Holmes. No one knows Professor Challenger, and Professor Challenger's freaking great. So that's essentially what this story is about, and they've worked this out from a series of ice cores, and that the temperature was just much, much warmer than we previously thought. But we're talking about twice the amount of carbon dioxide in the atmosphere as we've got today.
Wow, that's important to remember, folks, if you don't want to have a jungle at the South Pole and all the penguins having to lose all of their cold weather gear, whatever they're actually, I don't know what they actually use. Look, it's hard to even conceive of 90 million years ago, but to think just how different the planet would have looked then is just...
Yeah, you're talking about late Cretaceous, so you're talking like the tail end of the dinosaurs.
Ha, I see what you did there, nice pun.
Oh yeah, I'd forgotten that dinosaurs had tails.
Dinosaurs have great tails. Some of them with spikes, some of them with clubs, some of them with T-Rexes on the end.
Always when you know you've got the wrong end of the tail is when you find the teeth.
Although if you had to fight Stegosaurus, the other end of the tail isn't much better because that's got spikes.
Did you ever make the connection that Stegosaurus has the same number of syllables as Chucklevision, and that it fits quite well to the theme tune?
I never put that together, no.
I hadn't until just now when you said Stegosaurus.
Are you saying that I look like one of the Chuckle Brothers because of my beard?
I wasn't saying that.
Your subconscious was.
I can't imagine Freud wrote a lot about what it means to see one of your best friends as a Chuckle Brother, but I'm sure Freud would have written about it if the Chuckle Brothers had existed in his day.
Very probably. The Chuckle Brothers kind of remind... I imagine there were a lot of people who looked like the Chuckle Brothers in Freud's day, so maybe it just wasn't that... Maybe they were there.
Well, yeah, because people had more moustaches back then, didn't they? And everyone was from Yorkshire, weren't they?
I don't think everyone was from Yorkshire.
That's not what I was told in Yorkshire. In Yorkshire, I was informed that everybody from the past is from Yorkshire, or at least everybody important.
Everybody important from Yorkshire, yes, but not everybody.
So everybody important from Yorkshire was from Yorkshire?
Yes, and they're also magnetic.
Okay. Is that a segue?
No, but it's how I'm going to segue. It's a really bad segue. It's how I'm going to segue.
Okay. Magnetic Yorkshireman away.
Magnetism. I'm just like foregoing all pretense of a segue here.
Magnetic Yorkshireman.
So what I didn't know is there's lots of different types of magnetism, and from my understanding is it's based on how the electrons are aligned. So in normal magnetism that we're mostly familiar with, which is ferromagnetism, as in iron, ferros in iron, but all the electrons are aligned pointing in one direction, which is how you get the two poles and you get a magnetic field being created. And these are also used in computers.
Switch on, switch off.
Yeah, the ones and zeros are aligned correctly. Now, there's this other thing called anti-ferromagnetism, amongst many other types of magnetism, including paramagnetism, ferrimagnetism, superparamagnetism.
Tell me about superparamagnetism. That's a great phrase.
Yes, that's like I said, I didn't look into this too much because this isn't really what my story is about.
Okay, sorry. What was your story about?
The University of Central Florida is leading a multidisciplinary research initiative along with the universities of California, Santa Cruz, Ohio State University, New York University, and some others. And basically they were looking into anti-ferromagnets, which is where, again, from my brief understanding of this, is basically the electrons are pointing at each other, which it's probably a very simplistic way of thinking about it, but it basically means that they cancel each other out, so they don't actually have any magnetic moment. They don't create a magnetic field, which makes them kind of useless for doing anything, even though they are actually much more powerful. But what they found, and it was a guy called Enrique Del Barco who was leading on this, is that by passing electrical currents through antiferromagnets at the nanoscale, they can actually overcome this natural resistance and create magnetism. And they operate on the terahertz level, which means that they can complete calculations in a trillionth of a second, which basically means that computers would be much, much faster using antiferromagnets than magnets.
That's a real breakthrough.
Yeah. So huge breakthrough. They're going to, in terms of the next step, is to kind of have a better look at this, doing some more theoretical and experimental studies of it, and trying to figure out a way of, scaling it up, making it commercially viable. So early days yet, but just a really huge breakthrough, because it's kind of like suddenly realizing that rather than using a donkey to like pull your car, you can suddenly have a massive semi-truck or whatever they're called. to pull your goods instead. Like, it's just a huge breakthrough in terms of power and
Like a mechanical donkey.
like a mechanical donkey. Yeah.
I'm guessing it would be even better than that because if you're doing it at the nanoscale, presumably the amount of electricity required for a single switch on or off is lower, right?
It doesn't mention that in the article. I'd guess so as well. I'd imagine so as well. Although they could be.
I was imagining it as an energy saving thing as well as a massive increase in speed, which is like, it's fantastic. that's like everything you want.
Yeah, and much less electricity going through something as well. I mean, again, they kind of use the examples of guidance systems and communication systems and things like that here.
Have you ever Googled University of Central Florida?
I haven't, actually. Should I?
The building's kind of amazing if you look at it on Google Maps. It's sort of this perfectly...
Oh, wow.
It's these nested circles. Isn't it a fantastic looking piece of...
I mean, that there is a UFO that's landed.
Oh, yeah, exactly. But it's like it's a reasonably sized campus, and it really is exactly in the center of Florida, which, as everybody knows, is also the center of the universe, Orlando.
Yeah. It's very odd, though, because it's so circular, and then you zoom out a little bit and everything else is in a grid.
Yeah, that's what struck me about it. It was like an American structure that's not in the grid pattern. This just feels.
I mean,
wrong.
that's definitely that lends credence to my idea that it's an alien spaceship that's landed and it's disguising itself as a university.
What are the zombie things called in Minecraft?
The blow up things are creepers, and then you have actual zombies.
Yeah. Creepers is the ones that like go boom and break. Yeah, that's kind of my segue. So the creepers are my segue because they blow stuff up and leave you with just remnants of stuff. My next story is about Umau.
You pronounce this differently every time we talk about this.
That's my trademark. That's my stamp that I put on things. I mispronounce every word that I'm given.
I have often heard it pronounced Oumuamua. It is obviously up to you how you want to pronounce it.
Yeah, Oumuamua is an interstellar object which we believe to have been a remnant of a super Earth which got blown up. So a super Earth is just like a large Earth, right?
With Kryptonians on it.
Potentially. This is one of the things that I felt the story was missing, is that it didn't cover the possibility that Superman missed Earth because he wasn't that great at navigation.
He is just a baby, to be fair. It's his dad who shot him out in Oumuamua and missed Earth that should really be, scolded.
Yeah, he was under a lot of pressure, though, what with Krypton about to blow up, I think. And sometimes in those circumstances, they make bad decisions. I would say firing a baby into space under any circumstances isn't the best form of parenting.
Oh, wow. Okay.
Assuming that it didn't contain Krypton's last son, then there has to be another explanation as to why it was making this weird trajectory and why it was travelling at such speed.
And why it was that weird shape as well.
Yeah. This simulation of a large Earth going kaboom, which is the sound that all super Earths make when they blow up.
At that exact decibel level.
Yeah, it's... you think it would be louder. It's not. That model is the one that best fits the shape of the object. That's the model that they think is responsible for generating it. They think there's probably quite a lot of these objects out there. Like, there's probably regions of space which are just peppered with...
Superman baby cryopods. Sorry, with Oumuamuas, yes.
Honestly, if we can find a way of using the phrase cryopod with no context in every following episode of this, I am so on board with that as a project.
We'll do our best. But that's amazing. It's similar to the Uranus story. Like, it's incredible what scientists can model now.
But that was essentially my story, is that they tried a bunch of simulations and this was the one that fitted the best. And that was my story.
That's really cool.
How's that segue looking?
Well, if Superman had landed on this planet and landed in that wheat field may have been affected by Septoria tritici, which is a fungal disease. It's quite similar to another disease called rice blast, which sounds pretty fun, actually.
Oh, okay.
As many of you are probably aware, we try and protect crops against these things using fungicides at the moment. But a consortium of researchers from the University of Exeter, led by Professor Giraud Steinberg, I hope that's how you pronounce his name, Professor Giraud Steinberg, have identified novel monoalkyl chain lipophilic cations, or MALCs for short, which are really good at protecting rice and wheat from these two diseases. And these are staple crops around the world. They're really important, probably the two most important calorie crops in the world. So it's pretty important that we protect them even. And MALCs inhibit the activity of fungal mitochondria, which are the powerhouses of cells. And if you inhibit those, then basically the fungus dies, which is really useful. But the great thing about what they've created here is that they alert the plant defense system, so the plant itself can protect itself and look after itself, which is obviously really useful. It kills the fungus, but also it has no toxicity to other plants, which is sometimes a side effect of...
Oh, that's fantastic.
Yeah, which is a big problem with existing herbicides and fungicides already, and pesticides and things like that. And also it's a lot less toxic to aquatic organisms and human cells than existing fungicides that are used today. So all around, really good.
Is it effective against anything else apart from this rice blast equivalent for wheat? Or is it just that disease that it's able to take out?
I think as a base, because it inhibits the cell mitochondria in fungi, I think it can be applied to other fungi.
Other fungal stuff.
It's this really common one, which is the one they've targeted the most. But it seems to be at least form a base to research into other defenses against other strains. But they filed a patent for it, so they're getting far along. They're looking for investors and partners to help develop this further. But really important for somewhere like, for example, Bangladesh, where so many people are subsistence farmers, or their entire income is based on growing rice. Having this and protecting their health as well by using this instead is just a massive thing. And I eat a lot of bread, especially now. I like rice. If it's not going to kill me, then all the better.
Wasn't the story about wheat? You're talking about rice.
Sorry, it's
now.
both.
Oh, it's both. Oh, right. Oh, that's
yeah.
even
So
better.
sorry, it's these.
I didn't realise that. I thought it was just
no.
wheat.
So I think they're two related. So
fantastic.
The disease affecting wheat is called Septoria triticale, and then there's another thing called rice blast disease as well.
Yeah, I'd heard of rice blast. I thought it was just a comparison for something I would know.
No, so these are both what they looked at, and I think they're both caused by similar fungi, and this can help protect against both of those, it looks like.
That's fantastic. That's a really positive... I like that. It's a perfect, positive, upbeat story to finish on.
Ladies and gentlemen, and everyone else, thank you very much for listening. Please subscribe to the show to never miss an episode, and rate and review us wherever you have the power to do so. If you'd like to get in touch, or just find out a little bit more about our stories, or see some pictures, we are at Not a Buffalo Pod on Twitter and Instagram, Not a Buffalo Podcast on Facebook, and you can contact us through our website, notabuffalo.wordpress.com. Bye.